Welcome. Today we will be continuing with our discussions on excavation and loading. That is, today we will be discussing on dragline mining. In the last class, we introduced that how dragline can be used, and then also we have seen step by step how extended bench method is applied. But the most important thing in having any dragline deployed in the mining is to know whether we have selected that machine for the right job, and then our main objective is to draw the dragline balancing diagram. That is, the planning for a dragline pit is possible once we know that how the materials will be accommodated, the casted material will be accommodated on the floor, and for that we will have to deploy the machine by different approaches. So, today we will be briefly discussing all these methods of how dragline is deployed in a particular mine. So, we will start with first thing to recapitulate, why do we select dragline in surface mining? We know that yesterday we told you that dragline is a process, dragline mining is a process in which we do not require any transporting machinery, that is material is directly casted into the decolled area. So, the overburden is casted onto the decolled surface, and next thing is we can get a very high production rate. We have seen that your production rate, it can be say we have seen here 30 meter cube bucket capacity of a dragline, it can handle 4 million meter cube of overburden in a year. So, that is by only one machine you can do a good amount of mining. Then it is suited for, if the long reach is given, we can have 96 meter boom. So, it is for deep digging it can work, and high output are very essential things in case of deploying your dragline. Then another important thing is this machine has got a very long life. It can work before going for a major overhauling and repair up to 1.5 lakh hours. So, we can see that by a proper maintenance planning, this machine can work for a mine with a life of 25 years. So, by let us say, and then also it is a huge investment. Of course, this machine will be costing around 100 crore, and there is the main benefit of using dragline is the absence of auxiliary haulage units, your higher mineral recovery, your easy maneuverability, low maintenance costs, and operational advantages by for the other machines which will be working along with this. And then to maintain a very good geometry of the pit, that is also possible with the help of your dragline. That is why we use this dragline. And in India, we have got about in say 2004 there were about 43 draglines, and there were a few more have been erected. So, I do not know the exact number today, but it will not be more than 45 or 46. So, that many number of draglines are working in India. Their capacity, it will be varying from 5 meter cube bucket to 30 meter cube bucket. So, there is a good number of them are working in different parts of our country. As we told earlier also, that is northern coalfield is the place where a lot of draglines are used, but other coal mining subsidiaries of Coal India Limited are also using it. But now, what are the constraints? If you see, the main constraints of using this dragline is that it is not very suitable for very steep, that is if the coal seam is gradient is more than 1.1 in 6, then we cannot use this dragline effectively. And then this it cannot handle or negotiate many geological disturbances. We always say that is a flat terrain is suitable for this dragline. So, this is one of the constraint that we will have to use these machines only in flatter deposits, flatter seams. And then also it is suitable in case of a very long strike length, because in case of your short strike length, then the machine will have to turn number of times during the whole deposit excavations, and the turning and then shifting from one side to another, these are all time consuming things. So, if it can be worked along the strike length for a longer strike, say about 2 km, then this machine is very good. So, you have got now a rough idea about this applicability of this particular machine. Then how exactly you will deploy them? Now, for this deployment, you can see that there are the method of works can be by simple casting and without rehandling or with rehandling. You mind it that with dragline mining, it is invariably we will be having certain amount of rehandling, though we are not using other equipment, other transporting machinery, but the same machine may in some may or it is almost every mines, wherever they are using dragline, certain degree of rehandling is necessary. Now, this rehandling coefficient, it can go up to 0.4 sometimes. Normally, our mines are designed with rehandling of 25% or to 30% rehandling. It can be done economically, but if you know easily that more rehandling means more non-productive expenditures. So, we will have to take much care while designing the pit, so that rehandling can be minimized. Another thing is that we have got this simple casting, in which we directly throw the material to the decolled area, and that extended bench method, which I introduced to you yesterday. That is, we create a bench with the spoil dump, with the spoil material, and then you make this dragline to sit on it, and later on you again rehandle that material. That same thing, that extended bench method, it can be used also in another form, that is called your spoil bank method, which is also sometimes told as horseshoe or across pit method. Then we have got continuous bench 2 pass method, in which that on the same bench there is the work is carried out in 2 passes, and then there is a tandem dragline method, in which 2 draglines are used. This tandem dragline method can be of 2 types, just like your simple casting we have got without rehandling and with rehandling. Tandem dragline method can be with your vertical tandem and horizontal tandem. That horizontal tandem means that is your both the dragline will be in the same horizontal plane, or in some cases what may be there, one dragline is at a higher elevations, the another dragline will be at a lower elevations. You can easily think of that this type of situations may arise, where that your thickness of the overburden is very high. In that case, we may have 2 draglines are working for stripping out the same overburden bands, but sitting on 2 different levels. But in case of your horizontal tandem, that is your 2 dragline will be sitting on the same level. So, we will be discussing today this how these methods are exactly used. So, here is a case of your simple casting. You know that this diagram which is shown over here, it will be referred to as a dragline balancing diagram. Sometimes some people say it as a dragline range diagram. When you will be doing just mine planning and design, at that time we will be coming back to these diagrams little bit more and how to construct it. At this stage, you please know that it is nothing but it is a representation of that situations. We draw the in a range diagram, we draw the cross sections of the site in which it is working with the true dimensions of the machines and geometric dimensions of the pit, and we try to see that this material which has been excavated and placed, they balance together. So, why it is called a dragline balancing diagram? Because say for example, in this for a casting method, direct casting or simple casting, a dragline, it was first position set over here at this particular locations, and then it was giving the key cut. Yesterday also we told that while you are using a drag line, first it will have to give a key cut. For example, if you are having in a plan view, if you see, if the drag line is to work here, so what it will do, it will be first sitting over here, and then suppose this is your the high wall, that is which the mine is expanding in this direction. So, your this is the here, suppose you have got exposed this coal seam here, this is your exposed coal seam, this is your old coal here, and then you have got this is your overburden. Now, when the first the drag line will be sitting over here, then with that it will make a key cut. Here you will be giving a slot, these portions will be cut. So, what is done that when the drag line is sitting over here making this key cut, it will drop this material over here, and then this machine will then will be coming to these positions, and then it will cut the main portions. So, this is what in this case you can see the drag line sits on the immediate overburden bench. On this is it has removed by scraper on this topsoil here has been removed by scraper. Now, you can see here this is your a 3 meter of topsoil or the overburden has been removed by the scraper, and rest this 15 meter is there, in which they have created a 30 meter block. Now, when this key cut is made, depending on this slope and this slope, that whatever the wedge has been cut over here, this material is placed here. So, you can see that is this depending on the this is 61.25 meter away. That means, the drag line it is used at 10 meter cube shovel, 10 meter cube bucket capacity and 70 meter boom length. That 70 meter boom length, from here you can see that it is dumping or discasting the material at 61.25 meter. That means, you can easily now find out that is the boom 70 meter boom is having at an angle. You can calculate, you can determine that at what will be the boom angle of the drag line. Now, you see that this material will have to be accommodated over here. If these bands were up to this height, there were no that is removable by the scraper, that is 15, it would have been 18 meter. If the material were 18 meter, and that this particular material would have come, and instead of coming it over here, it would have come up to certain height, and the material would have come over here. Now, at this stage you can see here that there is a 10 meter of the floor is available, on which the machines which is excavating this coal seam, it can move. For their maneuverability of the shovel and the dumper, we have got a 10 meter space here in front of the overburden, which has been spilled by or direct casted by this drag line. Now, then what is done? Second thing, to give after giving the key cut, the drag line is going to its second position, in which it maintains a gap from the crest about 10 meter. These are the variables when you design a particular pit, when you work, these variables are to be decided. Here it is kept at a 10 meter. You remember that these are all blasted rock mass. Now, in that drag line is now sitting over here, its boom angle has been changed, or it has been made more horizontal, so that it can give maximum 66.5 meter by this 70 meter boom. So, this is the maximum reach which from this position the drag line can have. So, when the material is it started falling from here, a small windrow will be forming like that, and ultimately this material will make a line with that your previously that key cut material, and your spoil dump is formed. You can see that this line which is there in the previous cut, that is before this, that is your that when the next block is, that means as you can see here, this after giving the cut, this is one block 30 meter block, you can say here, there the drilling and blasting will be done. When this this spoil is now formed over here, a spoil dump will be forming over here. Sorry, this spoil dump is just forming like this. So, that before that there were, when this bench is advancing in these directions. So, when this wall, that is your high wall, this was here, when this wall will be cut, it will become here. So, you can see that this previous cut spoil was here. So, now when the next block will be cut, that your this one, another spoil dump will be coming over here. Then you use a dozer, this part, that upper triangle part can be made a fill over here, and then we can level this spoil dump. That is a different issue. We will be discussing how we manage spoil dumps later on. So, now what is here? This is a diagram by which you can see, if you know the geometry of it, if you know the material property, that is there will be a swelling of it. This is the bank volume, the blasted material. Now, this blasted material, whatever the volume is there, it will get swell when it is dumped here. This is a loose material. So, depending on that swell factor and the angle of repose of the material, it will form a geometry. When we draw a diagram maintaining this geometry and this swell factor and the angle of repose, we get exactly what can be the utilization of the space available over there, and that this representation, this diagrammatic representation is called dragline balancing diagram, or sometimes it is called range diagram. You can easily develop a relationship with this bench height, with this bench slope angle, with the swell factor, with this, and from there you can easily write some code to draw different type of balancing diagram for different situations. So, here you can see in simple casting, our width of the cut is normally kept less than 40 meter, and then what is the advantage of this? If we have a sufficient length of this dragline boom, we do not have any rehandling. This material has not come up to here, that is why no rehandling is necessary. But in that, in some cases when there will be your this thickness of overburden is more, then this material may come up to here, then we will have to do some rehandling job. So, does it give a clear picture of what is a simple casting by rehandling and without rehandling? These ones you can see in the plan view, that same thing, whatever was there, that key cut was there when the machine was sitting over here. Now, the machine giving the final cut, that is your the final cut, when it is giving, that spoil is coming over here. So, key cut spoil came up to here and the final cut, and these are the how layer that one these windows are formed, that is your overburden is getting spilled. So, this is your decold area. Decold area is getting simultaneously filled, that is your we are doing a backfilling as the dragline pit is advancing, your the overburden dump is being filled into the decold area or emptied pit, and we can start after it goes sufficiently distance. Now, we can level these two things, this can be level, and the reclamations, bioreclamations, plantations, and all these things can start over here. So, this is how a dragline mining. So, this is a direct casting. So, you can see here this dragline, it can give a swinging. Now, while operating, this is a very simple case, we are having a 90-degree swing and there is a very simple geometry, but in real life sometimes it may be necessary that we will have to handle differently. But in many of this dragline mining, you can find that this simple casting is available, and you can deploy, if you plan properly, you can deploy it. So, this is the diagram which can give you a little bit more visualizations. You can visualize this if your whole unit operations, how it is going on. You can see here drilling and blasting of the overburden is taking place over here in this site. the mine is getting advancing in this direction. So, we say this is the high wall, you know that below the high wall this is your overburden, this much thick overburden is there, and then there is a coal. You can see this is the coal is getting exposed by you have done the proper drilling and blasting. The dragline will be sitting on a blasted material, and then this blasted material will be scooped by the dragline bucket, and then it will throw or it will place over in a spoil dump bank. So, this is area where the material is your reclamation work is going on, and you can deploy a shovel and a dumper for collecting the coal. Okay. So, that is you do not have a say this is when here in this figure you can just think of that this is going up to here, when your this particular when this line of high wall, this is the new high wall, this is the old high wall. When this one was a new high wall, at that time this material dump were here. Now, when you are creating this new high wall, this much overburden has gone over here. Now, when this block will be cut, now this overburden spoil dump will be going on increasing over here. You can see a dozer is being used here. This dozer is leveling this, so that your, as you have seen, these things can be leveled put, and we can have a flatter surface of the overburden. So, this gives you a how dragline does the cast, and we are using a overburden dump or spoil dump is formed on the decoaled area, that this is the below that coal, this is the floor of the coal seam, and that once this coal is taken out, now this space will be ready. Now, when the dragline will be returning after going up to the end of the boundary of the your deposit or lease, then this dragline will start taking another block of 30 meter or 40 meter whatever it is, and the dragline will be moving in this direction, the face will be moving in this direction. At that time, this overburden will be placed over here, and this spoil dump will be growing and coming in these directions. So, does it give you an idea that what is a the dragline mining, in which how we proceed? Now, you can see here some another way, that is when you are using a simple casting, that we are doing the drilling and blasting. During the blasting, you remember in our blasting and classes we discussed about that there is called a throw blasting. Originally the surface was here, that when it was blasted, a mark pile was formed like this. You can see this is the mark pile formed, and then by bringing a dozer you level it, and then that is by making it in cut fill, here you are making a platform on which the dragline will be sitting. Now, you can see here the blasted material, when it has come this shaded portion, this material it is need not be excavated or need not be done anything, only this block here which is creating an obstruction, this is taken up. So, when you do the key cut material is placed at a point, so that it will be resting or it will be resting over the, that is your blast casted material. This material is cast by cast blasting, that mark pile was here. So, when you give this key cut material is placed over here, and then you mean that this is your main cut. When that main cut materials are going and placed over here, then you will be doing with the dragline rehandling of this casted material, this will also be placed over here. So, like that you can now see, if you draw a balancing diagram for these particular situations, you can easily, if you can calculate out that what is the mark pile profile, how much is the horizontal throw, and what is from this profile you can find out how much volume is here, and then ultimately this whole volume will have to be placed over here. You can see that this particular block, this block is the this whole material which was originally. So, if you balance this much, that means you are accommodating this. So, this is how you are depending on the dragline reach, depending on that how the throw is made, you can have a simple direct casting applications. So, direct casting, you have understood that it can be done with rehandling or without rehandling. It is also assisted by your by cast blasting. When you do a cast blasting, then it can help you in doing less job of digging by this dragline, but it may have to do a little bit manipulations and then negotiate the phase, so that it can throw the material away. Now, the next method, which is your extended bench method, we have discussed extended bench method in our introductory class. Here it is nothing but when your bench height is more, some material is put over here, this bench has been extended up to here, so that the dragline can sit over here, and after sitting here it will drop the material, and then afterwards this material will be again excavated and placed over here. So, that by this way we can handle the overburden material. This ones you can see a pictorial view. Here your drilling and blasting is going on. You can see that this is the old high wall, and here a new high wall is being formed by working with a dragline. This is the dragline. Now, here is another bench is there, which can be excavated by your pre-benching, it can be done, or this dragline can be placed over here and can throw this material also away from here. You can see that this dragline at present is sitting on an extended bench. This bench has been created in the previous cut, so that this material now being taken up from here, this is, and then it has thrown over here. But afterwards it will go to this position. After going this position, it will make a key cut here. After making the key cut, this material will be placed over here. When it will be placed over here, a new this type of extended bench will be created at this position, and then this will stand over here, and that material, whole material will be casted to this line. But otherwise, when the machine is sitting over here, that whatever is the cutting they have made, you can see that this is the line of your, and that means this boom, where it is this boom is here, it is dumping the material over here, and this is your how the windrow is getting formed. But when this machine was moving in this line, at that time this was the height where this material were spoiled down. So, this is how exactly an extended bench method works. Now, you can see here that the extended bench method, we have got the a topsoil layer, and we can see here this is coal seam is here. So, we have this dozer, is taking up this material and pushing it over here. So, the dozer mining, which we discussed in our site preparations discussions. So, dozer can help in your dragline mining. Then once this is formed, that your dragline is now sitting over here. So, it can throw the material at these positions, but this particular extended bench has been framed by means of this dozer. Now, then this whole material will be excavated by this dozer, and it will be placed over here. So, this is how an extended bench method can work when the material is pushed by dozer. So, difference of here the extended bench was made by the dragline itself. So, sometimes we can use it a dozer. Then you can see in the plan view what is done, that is your here the key cut is given. When the key cut is given, the material is thrown over here, and then this will be going to these positions and the material will be thrown over here, and this is the way the whole mine will be proceeding. So, this is the same thing that in a simple casting how we go with this. Okay. In case of extended bench, you can see here this material has been excavated by this drag line and placed over here. So, that this particular portion which will be forming an extended bench like this machine is sitting over here, it can move like this. So, this is how extended bench method works. We have shown you yesterday with a 3D diagram how extended bench method works. So, now the spoil bank method, the spoil bank method is one in which we create a heaps of material, that spoil bank, and there the drag line will be sitting down. It is having almost similarity with extended bench method, but little difference. Here when there are two seams are there, that means between two seams there is some interburden or parting. So, in that case we can use this drag line, and then from its first position drag line exposes the top seam by side casting the overburden above the top seam. The side casted materials are dosed and leveled to form the spoil bank. So, this in your extended bench, the level of the bench is the same, that is where the drag line was sitting, it will be moving in the same bench. But here because the two seams are there, that is the top seam is cut and then we are bringing this, the side casted material are dosed and leveled to form the spoil bank, and after extraction of the top seam the drag line is positioned on the spoil bank and the parting is loosened by blasting. Now, the loosened parting is removed by the drag line and side casted to expose the bottom seam. So, you can see here the diagram, we have got this two seams here, this is one seam and below that there is another seam. Now, we have got to remove this material. You can see that this drag line first remove this overburden and then this overburden is placed over here, and then when this overburden is removed, your this coal seam is exposed. Now, that your operation will be going on for excavating this coal seam. After excavating this coal seam, your this overburden dump is out. Now, after that the drag line will be sitting on this spoil dump, that is this is your spoil bank is created with the overburden of the top bench. Then by sitting over here it can excavate this overburden of this lower seam, and this material is casted over here, and then finally that whole overburden is placed over here and then your overburden dump is spent. So, you can see here there is a movement of the drag line from the top bench overburden to the spoil bank, and then you do it over there, and that the same thing can be repeated. So, the overburden removal by spoil bank method is done wherever this type of two seams are there. You can see here in a spoil bank method balancing diagram, this is the top seam and this is these two seams are also there. So, you can remove you can make this portion this drag line is sitting over here and this material is thrown over here, and then this has gone that this machine will be coming over here, and from there it will be cutting this lower parting of it and it will be placed over here. So, this is the way how the drag line balancing diagram will have to be drawn. say the other method, that is a continuous bench 2 pass method. Here what is done, this is the same seam, but this is with this drag line it will cut the material and then up to certain level it will make a bench here, continuous bench of the with the spoil dump. That is, your spoil dump is placed over here, that by dozer you level it over here. So, that now the spoil dump will be spoil dump in this side and the part of the bench they are combining together. Now, in the second place what happens, this part with now with this spoil dump. Only thing is, when it is sitting over here, now this material in R, this is your rehandle and this material is placed over here. So, that ultimately you will be removing all these C portions and these R portions and you will be getting this configuration. So, this is your what is called your continuous bench 2 pass method, that is, in the first pass you do the key cut and also you remove a part of it, and after doing that you make a bench which looks like a continuous with the, that is your the bank here, which is the blasted rock and which is the loose your casted spoil. These two make a continuous bench and the dragline sits over here and manipulate to expose this coal seam. Does it give you an idea about now what is this continuous bench 2 pass method? That means, the overburden here also it will have to be a thicker overburden. The thick overburden is cut in 2 passes, that is right. But while doing the 2 passes you maintain a continuous bench with the this continuous bench with the spoil and the blasted mass, right. Then second thing is, next method will be your tandem working of dragline. This is what is very important, because many of our northern coalfield mines they are always using this tandem dragline. Now, 2 draglines together at 2 levels with 100 meter horizontal distance, sometimes it can be up to 200 meter distance also, and they are used for more than 30 meter thick coal seams with 60 meter overburden bench. So, first thing, where do you use a tandem working dragline? Where the coal seam is a very thick seam mining and also overburden is sufficient depth. So, that is your thickness of the overburden is also more and you have got more coal seam thickness also. Then you can see here how the work is done in the balancing diagram. You have that is 2 part here, that is the dragline position, that is one dragline is here and then another dragline can sit over here, and then we can work with this 2 dragline to remove this material. Let us see that these 2 ways, that is we have got this 2 dragline, that is horizontal tandem. You can see both the draglines are on the same level. Here some interesting thing you can see here, that the first one it will give the key cut. When it gives the key cut material is placed over here, which will be rehandled, and then after giving the key cut it moves to this second position and then it gives the first cut, and this first cut material is placed over here, and then the second one it will be sitting over here, it rehandles this part, that is, and make this first dig, that is there this part is cut along with that whatever is to be rehandled and then push them it further. So, that ultimately your material is placed over here, but you can see here this is the coal seam, a wedge of coal seam is left here under the overburden. That means, this much coal is not excavated, what they do, they are just holding this overburden against it. So, a rib of coal seam here, this must maybe a 5 meter at the bottom, this is left with. This is how a horizontal tandem overburden work. So, these situations can be drawn and while drawing a your balancing diagram. That means, how much volume will be going over here, whether if we can cut this without this wedge, then what should be there. That means, this material will have to be accommodated from here or it will have to be accommodated from here, which can be possible if you use a bigger dragline. If the boom is much more, then instead of cupping it over here, it will be going. But thing is that sometimes it may be economic in whatever the investment will be required to get this small strip of coal, the machine with a very longer boom may be having very cost and also maintenance issues. So, this is what. Now, you can see the plan view in a horizontally how it is done. As we have seen here, this key cut is given. You can see here this drag line, it was sitting over here to give a key cut first. Then after giving this key cut, you can see here this is after giving the key cut, it has formed this wall and then it has gone over here. As you can see here, this has moved to there to give the first cut. So, that means, this is the portion which is giving the first cut is cutting. Then what happens? This key cut material is spoiled and kept over here. This is the spoil dump. Here some of the key cut material has done. Now, this is the you are going on excavating in this direction overburden. So, this spoil and that key cut, next key cut will be given, the material will be coming over here, this platform will be going in these directions. So, the second drag line, it is the second drag line is placed, this one is placed on this rehandle material, this material which is to be rehandled. That means, while giving the key cut and while doing this your first cut, this material is coming over here just like a spoil bank, and that second drag line is positioned on this loose material and it starts cutting from here, and then it will be excavating these portions, whatever it is a part of rehandled part, that is more than this, and exactly you can think of from this line. That means, this part is rehandled one, this is only the blasted one. So, this drag line mainly get this rehandled part and then it is placed a little bit away. As you can see here, this drag line, it is placing the material at a distance. This one was capable of placing the material only up to here. So, when it has done this, this plan is formed. So, that is how in a plan view you can see that how drag line is working. So, you can combine these two, that how, if you know that to draw the balancing diagram, from there you can draw the plan view. So, here I have seen this is a construction lines are shown here. You can see that this is your original, that is the bench. So, it is in this slope, you can see here this bench is here, this is the high wall, this high wall here. Now, here you are giving a box cut to give this key cut or box cut, this key cut material, you can see that after giving the key cut, your this face is created. Once this face is created, then you can move this once, and then when your cutting here, this is one bench which is exactly you can see here, this particular bench here, this is one bench, then this bench, and then you can see from these two your here that material, this bench, you can see that this is the overburden spoil here, this bench. Similarly, this particular one, you can see that this is the line, this center line is here. So, we are having a ridge like this. So, this is the way how you can use the cross section to draw the plan view. So, what are the sequence operations in a horizontal tandem? Provide the key cut by positioning the leading drag line. That means, this is your leading drag line and this is your lagging drag line. Now, this leading drag line is placed at axis 1 and then move it to axis 2 and provide the first cut. This first cut is given next to the key cut, that is next to the key cut this first cut is given, and then this it will be going to further this side, and drag line 2 will be, that lagging drag line will be placed over here. Okay. Now, this will be doing this cutting the first deck and the rehandle material, and then it will place over here. So, dragline 2 also rehandles the loose overburden to expose the coal seam, because you can see here the coal seam is up to here, it was your blasted rock, but here the coal seam was also below the spoil dump. So, this portion when it is rehandled, the whole coal seam get exposed, and then you can use the other machines. Now, only this ridge is left, which is the pointer. So, does it give you an idea about when we say that dragline at tandem? So, dragline at tandem can be of two types. Your first is tandem at horizontal tandem, and then with the vertical tandem. Now, in the horizontal tandem, what is done? That is the leading dragline, it gives the key cut, and then it gives the your first cut. The key cut and first cut spoil is placed, and then on the platform where this your lagging drag line will be sitting on, and the lagging drag line in fact will be throwing this material further away, so that your whole coal seam will be exposed, right. So, now next thing is your vertical tandem. Now, what I said vertical tandem means the two drag lines will be at two levels, as this diagram has shown, that is you have got one drag line at this level and the other drag line at this level. We say that this one is our leading drag line, which will be giving the key cut, and then this is our the lagging drag line or the drag line 2, which will giving the doing the rehandling part. In this particular also we have designed this particular one with a leaving a wedge of coal. This is called your wedge loss, that if it is a 2 kilometer strike length, then if it is a 5 meter with this particular amount area, you multiply it with the strike length, that much coal is being lost every time. Now, what is here, you just see the range diagram in which we can see number of things. The coal seam is getting cut, that is the coal bench slope angle is 80 degree, and your overburden bench, they have got this 3 benches of overburden, that is a very thick overburden, where 70 degree is the slope angle. Now, there is a pre-benching done, that is to reduce the thickness of the overburden, you normally do a pre-benching, where you have used a shovel and dumpers are used. The shovel and dumper will be removing this top layer. So, we are left with these 2 benches. Now, in which the drag line will be placed on the top cut, and the your other drag line will be getting onto the rehandled material. Here also you can see the how it exactly work. This high bench is divided into 2 vertical benches, upper bench or we can say top bench, which is less thicker. Normally, we can see here if it is 20 meter, it is 30 meter. So, that means this one, the top bench top slice is your thickness of the bottom slice is more than the top slice, and then dragline 1 is positioned on the upper bench. It is placed positions over here, and this it excavates the overburden and side cuts the spoil into the decoaled area, which extends the main bench. This one is taking the one and it outcasts in this area, but the whole thing is not there, it just touches this. Okay. So, after sufficient advance of the top deck, the same dragline comes down to the main bench. So, what is happened? This top cut is made and the same dragline will be sitting over here, okay, and it will give the key cut now. then that key cut material is side casted into the decolled area and to form a level bed to create the sitting space for the legging dragline. So, in the decolled area now it has created a bench where this that your second or legging dragline will be sitting down, and then dragline 2 is placed on the lower bench to excavate the first dig portions and subsequently march towards the spoil site to sit on the level bed to rehandle finally. So, our whole coal is exposed in this. So, you can draw that your balancing diagram in cross sections. From there you can construct the plan view, which is the work. If you want to learn, you will have to do this. So, you can remember that the operational parameter for doing the whole productivity calculations, you will require that how the swing angle is negotiated, how the boom angle, bucket size, boom length. So, some of the typical values for 2496 dragline is given over here. With this you can create some, say, a problem. You note down this problem, you will have to solve by yourself. The key field parameters are given over here, that is what are the different cut width, strip width, high wall slope, band slope, key cut slope. Now, and that with these parameters details given, you can now create a construct a balancing diagram for this application. Similarly, here some this for the same given parameter, how can you draw a diagram for the balancing diagram for your vertical tandem operations. Please do these problems, and if you can see that this type of solutions will be coming out of it, which is your self learning problem, you must do it. And for doing it, you can read some of these very good articles which are available, and that will help you in understanding what is dragline mining. And only thing is, unless and until you do these practices and draw some of the balancing diagram by yourself, then things will not be very you will not be able to solve the practical problems. Please see the SME handbook, that is a surface mining book by Kennedy. There are also some examples are given, some case studies of different dragline minings are there. So, in your portfolio, I want you please start collecting some of the case studies and then how dragline mining is done. So, you can prepare and solve some of the problems, then you will be learning how dragline mining is practiced in our country and abroad. Thank you very much.